In 1962, a nuclear bomb detonated 250 miles above the Pacific Ocean, killed 300 streetlights in Hawaii, 900 miles away. The military spent billions learning to stop it. They classified the solution, then deleted it from every field manual. The fix cost $2. Commercial Faraday bags run $30 to $100 for a single phone-sized pouch. Military-grade facility shielding costs millions per installation. The physics behind both is identical to wrapping your electronics in grocery store aluminum foil. 3 layers? $2. Same principle the Pentagon stakes nuclear command and control on. By the end of this video, you will know exactly how to build, test, and store a Faraday bag that protects every critical device you own. The document that explains exactly how vulnerable your electronics are is called MIL-STD-2169C. You cannot read it. It requires a security clearance. But I'm going to show you everything you need to know using the government's own unclassified paperwork. By the end, you'll understand why they never wanted you to have this information in the first place. To understand why this was buried, you need to understand what it stops. This channel exists because the information that could save your family shouldn't require a security clearance. Every video on this channel takes something the government knows, something the military relies on, and makes it accessible to the people who were never supposed to have it. If that sounds like a mission worth supporting, subscribe. Not because I need the numbers, because the next piece of buried knowledge should find you before you need it. Let's start with the moment the government realized EMP could end everything, and what they did next. 1836, London. A scientist named Michael Faraday builds a room-sized cage lined with metal foil. He charges the exterior with an electrostatic generator. Then he walks inside with the most sensitive instruments available. Nothing, no charge, no field, no effect. The electricity flows across the surface and never reaches the interior. 190 years ago. The physics has never been disputed, not once. Fast forward 126 years. July 9th, 1962. The United States detonates a thermonuclear warhead called Starfish Prime. 1.4 megatons, 250 miles above Johnston Atoll in the Pacific Ocean. This was not a secret test. It was well documented. What happened next was not expected. 900 miles away in Hawaii, 300 streetlights went dark simultaneously. A microwave telecommunications link was destroyed. Burglar alarms triggered across Oahu. Navigation systems failed. The measured field strength at that distance was 5,600 volts per meter at 900 miles. From a single detonation in 1962. Here's what they calculated later. If that same weapon had detonated over the continental United States instead of open ocean, the field strength would have reached 22,000 to 30,000 volts per meter across the entire lower 48 states. Every unshielded electronic device in the country exposed simultaneously. But it gets worse. The same year, 1962, the Soviet Union conducted its own test. Test 184, 300 kilotons, smaller than Starfish Prime. But the Soviets did something the Americans didn't. They detonated over populated land, over Kazakhstan. The results were catastrophic. A fire broke out in the Karaganda power plant. Overhead power lines generated voltage spikes that destroyed equipment connected to the grid. The damage was worse than Starfish Prime despite the smaller yield, because the weapon was positioned over infrastructure, not open ocean. 2 superpowers. Same year, same conclusion. Electromagnetic pulse from a high-altitude nuclear detonation can destroy electronic systems across hundreds of miles. This is not theory. This is measured, documented, exposed in declassified reports you can read today. And the principle that stops it? Faraday figured it out in 1836. Wrap a conductor around something. The electromagnetic energy flows across the surface. The interior stays clean. 190 years of proven, unchallenged physics. So how does a $2 roll of foil stop something that knocked out streetlights 900 miles away? The answer is the same physics the Pentagon uses, and it's simpler than you think. Everything I'm about to show you in this video is the surface layer. The research behind it goes much deeper. The vault is where I keep the full documentation archive. Congressional Commission transcripts, declassified test reports. The unclassified military standards the Pentagon built its entire command and control shielding program around. Equipment lists with exact product comparisons. Testing protocols beyond what I can cover in a single video. No filler, no fluff. Just the research library the government never built for you. The link is in the description. But stay here. Everything you need to build and test your first Faraday bag is coming in this video. The vault is for those who want to go deeper. Now, the physics. And I promise, this is simpler than they want you to think. An electromagnetic pulse from a nuclear detonation has 3 components. They are designated E1, E2, and E3. Each one threatens different things in different ways. E1 is the killer. It arrives at the speed of light, It lasts nanoseconds. And it generates field strengths between 25,000 and 50,000 volts per meter. That is the one that destroys small electronics, phones, radios, computers, charge controllers, anything with a semiconductor. E1 is what your Faraday bag needs to stop. E2 resembles lightning. Your electronics are already built to handle some of this. It is a concern, but it is not the primary threat to small devices. E3 is the slow pulse. It lasts seconds to minutes. It threatens power grid infrastructure, transformers, long transmission lines. Your Faraday bag does not need to address E3 because E3 target system's too large to fit in a bag. So your job is stopping E1. Here's how it works. When electromagnetic energy hits a conductive surface, the current flows across that surface. This is called the skin effect. The depth to which the current penetrates is measured in microns. For the frequencies generated by an E1 pulse, that skin depth is extremely shallow. Heavy-duty aluminum foil is 24 microns thick. That single layer already approaches the minimum shielding thickness needed for E1 frequencies. 3 layers is 72 microns. Each layer acts as an independent Faraday cage. The energy that penetrates the first layer encounters the second. What penetrates the second encounters the third. But here's the critical detail most people miss. The device inside must not touch the foil. If your phone is in direct contact with the conductive surface, the energy can couple directly into the device. You need an insulating layer between the device and every layer of foil. Cardboard, cloth, plastic, anything non-conductive. This is not speculation. This is how every commercial Faraday bag works. This is how every military shielded enclosure works. The principle is identical. Conductive shell, insulating gap, conductive shell, insulating gap, nested cages. Now here's the part that makes this undeniable. In 2019, the Cybersecurity and Infrastructure Security Agency, CISA, published guidelines on electromagnetic pulse protection. In that document, they established tiered protection levels. Level 1, 30 decibels of attenuation. That is a 97% reduction in field strength, and CISA acknowledged it as meaningful protection. 30 decibels, 97%. The government quietly validated that even basic shielding works, in a document most people have never heard of. The military standard for hardened facilities is MIL-STD-188-125. It specifies shielding requirements for command, control, communications, computers, and intelligence infrastructure. C4I. The same Faraday principle, scaled up, applied with precision engineering and quality control, but the same physics. Conductor, gap, conductor, gap. Shield the interior from the exterior field. And MIL-STD-2169C, the one that tells you exactly how bad an EMP event would be, the one that would let civilian engineers design proper protection, classified. You cannot read it without a security clearance. The document that describes the threat is locked away from the people the threat would kill. The military knows this works. They've spent billions proving it. So why does the commercial market charge you $50 to $100 for a bag that does what $2 of foil can do? Let's talk money. A phone-sized commercial Faraday bag costs $30 to $100. A tablet or laptop bag runs $50 to $300. Equipment enclosures start at $500 and climb from there. Military facility shielding runs millions per installation. Companies like Mission Darkness, Tech Protect, and Faraday Defense dominate this market. And here's the thing. Mission Darkness certifies their products to MIL-STD-188-125, the military shielding standard, using the Faraday principle, the same physics as aluminum foil. What do you get for the extra $98? Durability, convenience, a certification number, consistent performance, across a wider frequency range. These are real advantages for law enforcement who use commercial Faraday bags every single day to prevent remote wiping of seized phones during criminal investigations. That is not theoretical use. That is operational, trusted, daily. But the physics is identical. So why doesn't everyone know that $2 of foil does the same job? Because aluminum foil cannot be patented. There is no proprietary formulation, no subscription model, no recurring revenue, no corporate advocate, no marketing budget. Nobody profits from telling you this works. The commercial manufacturers serve institutional buyers who need certification paperwork. The foil sitting in your kitchen drawer has no lobbyist. Before I show you exactly how to build this, I need to be honest about what it can and cannot do. If you've made it this far, or you already know more about EMP protection than most people will learn in a lifetime, subscribe so the next piece of buried knowledge finds you before you need it. Share this video with one person you care about, because this information does nothing sitting in an algorithm. It works when it reaches the people who need it. Now, the honest limitations. I'm not going to pretend this is perfect. Here's what you need to know. First, aluminum foil is fragile. Commercial bags use woven metal fabric that survives handling. Foil tears. Your DIY bag is a storage solution, not an everyday carry pouch. You wrap it, you store it, you leave it alone until you need it. Second, the AM radio test I'm about to teach you covers the AM broadcast band, 530 to 1,700 kilohertz. That is not the full EMP frequency spectrum. It is a useful indicator of shielding effectiveness, but it is not a comprehensive certification test. Third, I cannot tell you the exact attenuation value of your DIY construction. It might be 30 decibels, it might be 60. It depends on how well you seal the seams, how many layers you use, how carefully you insulate. There's no civilian testing program that has measured this precisely, and I'll explain why in a moment. Fourth, this protects only what is inside the bag. Your house wiring, your car's electronics, the power grid. None of that is protected by a Faraday bag. This is about preserving critical backup devices. Fifth, there is genuine scientific debate about how much damage one causes to small electronics that are disconnected from the grid and turned off at the moment of the pulse. Some researchers argue the coupling is minimal. Others argue the semiconductor pathways are vulnerable regardless. The honest answer is that the classified test data that would resolve this debate is locked inside MIL-STD-21169C. Sixth, stored devices require maintenance, batteries degrade, firmware needs updates. You need to check your stored devices periodically. And here's why comprehensive civilian testing doesn't exist. From 1992 to 1995, the Department of Defense ran the ELECTRA program. It was designed to improve predictions of EMP effects on military systems. The result? Expert predictions before testing differed significantly from actual test outcomes. Even military engineers with access to classified threat data couldn't reliably predict what would happen. The data needed to design proper civilian protection tests is itself classified. Circular suppression. The information required to validate your protection is restricted from you. These are real limitations. But the alternative, doing nothing, has no limitations debate. Zero protection is zero protection. With all of that on the table, here's exactly how to build it. Materials: 1 roll of heavy-duty aluminum foil, not regular foil. Heavy duty, 24 microns thick. Cost is approximately $2. Cardboard from any box you have at home, free. A cloth bag or plastic zip seal bag for each device. Free or nearly free, standard tape. You already own it. Now, which devices go inside? This matters more than the bag itself. Priority 1, an AM, FM, and shortwave radio. The emergency alert system broadcasts on AM and FM frequencies. Shortwave reaches international broadcasts. This is your primary information source when the grid is down. Protect this first. Priority 2, LED flashlights. The semiconductor drivers inside LED flashlights are vulnerable to E1. Protect at least 2. Priority 3, a spare smartphone, not your daily phone. A backup, loaded with offline maps, medical references, survival guides, family documents. It becomes a computer when the grid is gone. Priority 4, a battery charger compatible with your stored devices. Priority 5, a USB solar panel with a charge controller. The charge controller has semiconductors. It needs protection. Priority 6, spare batteries for everything in the bag. Lithium, alkaline, rechargeable. Whatever your devices use. Priority 7, USB drives loaded with critical documents, medical records, insurance information, family contacts, offline reference materials. These are backup devices. Not everyday carry. They stay wrapped and stored until the day you need them. Construction? Step 1. Take your first device and place it inside a cloth bag or plastic bag. This is your innermost insulating layer. The device must not touch foil at any point. Step 2. Tear off a sheet of heavy-duty aluminum foil large enough to wrap the device completely with at least 2 inches of overlap on every seam. 2 inches minimum. This is not negotiable. Gaps in the seam are gaps in your shielding. Step 3. Wrap the device completely. Fold all seams tightly. Press the foil smooth against itself at every overlap. No holes, no tears, no gaps. Step 4. Wrap the foil-covered package in another insulating layer. Cardboard works, another cloth bag works, another plastic bag works. The insulator just needs to prevent the next foil layer from electrically contacting the first foil layer. Step 5. Wrap in a second complete layer of heavy-duty foil. Same rules. 2-inch overlap minimum, tight seams, no gaps. Step 6. Add a third insulating layer. Step 7. Add a third and final foil layer. 3 foil layers minimum, each separated by insulation. 3 independent Faraday cages nested inside each other. Step 8. Wrap the entire package in a final protective layer. Cardboard cloth or plastic bag. This protects the outer foil from tears during storage. Step 9. Label the package. You will not want to unwrap everything to figure out what's inside. Step 10. Test it. Take an AM radio, turn it on, tune it to the strongest local AM station. Confirm you can hear the broadcast clearly. Now place the radio inside your completed Faraday bag. Wrap it fully. Same standards. 2-inch overlaps, 3 foil layers with insulation. If the shielding works, the AM signal will drop dramatically or disappear entirely. If you can still hear the station clearly, you have a gap. Unwrap. Find the weak seam, rewrap. Test again. This test is not a full spectrum certification, but it is a real, verifiable, repeatable indicator that your shielding is attenuating electromagnetic energy. You can do this tonight in your kitchen for $2. Store your completed bags in a dry location, away from house wiring, away from plumbing, disconnected from everything. A closet shelf on an interior wall works. A plastic storage bin in a basement works. The bags should be accessible but undisturbed. You now know how to do something the government has never taught a single civilian. Let me put this journey in perspective. In 1836, Michael Faraday proved that a conductive enclosure blocks electromagnetic fields. 190 years of unchallenged physics. In 1962, Starfish Prime proved that a nuclear detonation in the upper atmosphere destroys electronics across 900 miles. The government measured it, documented it, then classified the detailed threat parameters. The Congressional EMP Commission was authorized 3 separate times. Fiscal year 2001, fiscal year 2006, fiscal year 2016. They published reports in 2004, 2008, and 2017. Their conclusion? Electromagnetic pulse represents an existential threat to the nation. Existential. Their word, not mine. Former CIA Director James Woolsey testified that a prolonged nationwide blackout caused by EMP could result in the death of up to 90% of the American population within a year, through starvation, through collapse of medical infrastructure, through societal breakdown. The estimated cost to harden the national electrical grid against EMP, $4 billion. It was never funded. The EMP Commission's final report wasn't even hosted on a government website. The chairman had to post it on his personal site to keep it publicly accessible. NORAD moved back inside Cheyenne Mountain. The reason they gave publicly? EMP protection. The military protects its own command and control. The grid that keeps 330 million people alive? Self-regulating. The EMP Commission specifically identified the electrical utility industry as the only critical infrastructure sector that is substantially self-regulating on EMP resilience. The government calls this an existential threat to the nation. And the fix for your family costs $2. You cannot patent aluminum foil. You cannot classify Faraday's discovery. You cannot erase Starfish Prime from the historical record. The information is not secret. The technique is not classified. The materials are not restricted. The only thing that was missing was the instruction. Now you have it. Build the bag tonight. Test it with an AM radio. Store the devices your family would need if the grid went down for months. And share this video with someone who deserves to know what you now know. Because this information has been available for 190 years. It just never had a marketing budget. Next week, we go deeper into something the EMP Commission buried in the appendix of their 2008 report. Something about the water supply. Make sure you're subscribed so you don't miss it. I'll see you there.